Hello everyone, in this video we will see the derivation of radius of curvature for Cartesian curve y is equals to f of x. That is, show that rho is equals to 1 plus dy divided by dx whole bracket square raised to 3 divided by 2 divided by d square y divided by dx square. Otherwise, rho is equals to 1 plus y1 square raised to 3 by 2 divided by y2. So if we want to show this result, so let us consider the axis. So this is the axis x o x dash, y o y dash. Now here one Cartesian curve. So this is y is equals to f of x is the Cartesian curve I am going to consider. Let A be the fixed point and P and Q are another 2 points on the curve. Next, from the point P, draw one tangent line, and from the point Q, draw another tangent line. Next, from P and Q, we need to draw two normal lines. Okay, the line which is perpendicular to the tangent line, we are going to call it as normal line. Therefore, from P one normal line and from Q another normal line. Then this AP distance is S, PQ distance is delta S, and this angle becomes delta psi, and this point is N, and this is a center. Now from this figure, the tangent of the curve, at a point P, makes an angle psi with x-axis. Means from this figure, this is the tangent line. The tangent line makes an angle psi with x-axis. Now, by the definition of derivative, so in differentiation we know dy divided by dx is equals to tan theta, but here angle is psi, therefore I am going to consider tan psi. This I am going to call it as equation number 1. This indicates the slope of the tangent line, that is dy divided by dx is equals to tan psi. So this differentiate with respect to x. That time dy divided by dx differentiation with respect to x becomes d square y divided by dx square is equals to, again we know differentiation of tan x is equals to sec square x. Therefore, differentiation of tan psi becomes sec square psi into psi differentiation with respect to x is d psi divided by dx. So that is the chain rule, because here we are differentiating with respect to x. Now from trigonometry we know next d square y divided by dx square is equals to, from trigonometry identities we know 1 plus tan square theta is equals to sec square theta. Therefore this sec square psi I am going to replace by 1 plus tan square psi. Next, here d psi divided by dx can be written as d psi divided by ds into ds divided by dx, because suppose if I cancel ds and ds, again what I am getting, d psi divided by dx. Therefore remember, d psi divided by dx can be written as d psi divided by ds into ds divided by dx. This I am going to call as 2. Now from 1 we know tan psi is nothing but dy divided by dx. Correct. Here tan psi is there, that's tan psi is nothing but dy divided by dx. Next, this d psi divided by ds, this is nothing but the curvature formula. Curvature, d psi divided by ds is nothing but k, that is the curvature. Again we know this curvature is reciprocal of radius of curvature. Therefore that k itself is nothing but 1 divided by rho. Next, another one, the ratio. What is that ratio? ds divided by dx can be written as square root of 1 plus dy divided by dx whole bracket square. So what this indicates in this curve, it is the length between from the point P to Q, the length between P and Q. So this length is nothing but ds divided by dx is equals to square root of 1 plus dy divided by dx whole bracket square. So that indicates ds divided by ds divided by dx indicates what? The arc length. Therefore ds divided by dx is square root of 1 plus dy divided by dx whole bracket square. Next, what I am going to do, these three values here I am going to substitute. Therefore 2 becomes, equation 2 becomes, left hand side d square y divided by dx square, keep it as it is, d square y divided by dx square is equals to, next 1 plus tan psi is nothing but dy divided by dx, but the power of tan is square, therefore it becomes dy divided by dx whole bracket square. Next, d psi divided by ds is nothing but the curvature, that is k into k into the ratio ds divided by dx is square root of 1 plus dy by dx whole bracket square. So that is square root of 1 plus dy divided by dx whole bracket square. Next, we need the radius of curvature. Therefore in the next step, d square y divided by dx square as it is equals to, again in bracket 1 plus dy divided by dx whole bracket square, keep it as it is. Next, this curvature is a reciprocal of radius of curvature, so k can be written as 1 divided by rho into square root of 1 plus dy divided by dx whole bracket square, keep it as it is. Next, we need the radius of curvature. Therefore I am going to do the cross multiplication. So that time, therefore rho into d square y divided by dx square is equals to. So here in the right hand side remaining value is bracket 1 plus dy divided by dx whole bracket square into square root of 1 plus dy divided by dx whole bracket square. Next, here 1 plus dy by dx whole bracket square, here power is nothing but 1. So if I remove the square root, that square root becomes 1 divided by 2. So that time 1 plus 1 divided by 2. That time basis will remain same, add the power. So if I take the LCM, 1 plus 1 by 2 becomes what here? 3 divided by 2. Therefore, rho into d square y divided by dx square is equals to, this can be written as in bracket 1 plus dy divided by dx whole bracket square raised to, this becomes 3 divided by 2. But we need only the radius of curvature. Therefore, rho is equals to in bracket 1 plus dy divided by dx whole bracket square raised to 3 divided by 2. Then this value comes in the denominator divided by d square y divided by dx square. So this is the formula. So this is the formula for radius of curvature for Cartesian curve. Here if I take in place of dy by dx y1 and in place of d square y divided by dx square second derivative y2. First derivative sometimes we denote by y1, second derivative sometimes we denote by y2. So that time rho is equals to, this formula becomes 1 plus dy by dx is nothing but y1 power is square raised to 3 divided by 2 divided by d square y divided by dx square becomes what? y2. Therefore, so this is the formula for radius of curvature for Cartesian curve.